All right, so for this first problem, we want sine x greater than or equal to 1/2 to begin with. So isolate the sine function. And sine is never undefined, so we don't have to worry about that. But sine is equal to positive 1/2 in quadrants 1 and 2, and the reference angle is pi over 6. So the two critical numbers are pi over 6 and 5 pi over 6. And those need to go on a number line. We're looking for answers on the interval 0 to pi over 2. To 2 pi. And so pi over 6 can be somewhere, and 5 pi over 6 can be somewhere. And you don't have to draw the unit circle over here, but if it helps you figure out which angles you're allowed to choose between, you can. So that would look like this. I've got 0, I've got pi over 6, I've got 5 pi over 6. And so we're just saying we need to pick something between 0 and pi over 6, something between pi over 6 and 5 pi over 6, and then something between 5 pi over 6 and back to 2 pi. So you are allowed to plug in 0. So you can say sine of 0 is supposed to be greater than or equal to 1/2, and then we're just checking to see if this is true or false. So sine of 0 is 0. That is not greater than or equal to 1/2. So nothing in this first section will work. That way we don't have to pick like pi over 12 or something like that. In between pi over 6 and 5 pi over 6, a good angle would be pi over 2. So this circle just helps you visualize that. If you don't need that, if you can get that right from this number line, that's fine too. So sine of pi over 2, is that greater than or equal to 1/2? So sine of pi over 2 is 1, which is greater than or equal to 1/2. That's true. So this is part of the solution set. And last one to check would be something between 5 pi over 6 and 2 pi. You could pick pi, 3 pi over 2, 2 pi. Anything in here is going to work. So let's just say we do 3 pi over 2. Anything we pick in this realm should give us the same conclusion, so it doesn't matter. So sine of 3 pi over 2, we're checking is that greater than or equal to 1/2? So sine is -1 at 3 pi over 2. That's not greater than or equal to 1/2. So that's false. So the only solution set for this first one is pi over 6. Oh, and they should be closed in because this is greater than or equal to. So square brackets, pi over 6 to 5 pi over 6. All right. Tangent and cotangent, those problems are a little bit harder. Because you also have to consider where the graph is undefined. So first off, I isolate this. Tangent x is less than -1 over radical 3. So I need to get those x values. So that happens in quadrants 2 and 4, where tangent's negative. And the reference angle that makes tangent 1 over radical 3 is pi over 6. So the two critical numbers are going to be 5 pi over 6 and 11 pi over 6. But then we also have to remember that tangent x is undefined at pi over 2 and 3 pi over 2. And that'll always be the case. If it's just tangent x, that's where it's undefined. So then again, I need a number line. So it starts at 0, it ends at 2 pi. You want to make sure you get these in order. So 5 pi over 6 is after pi over 2. So the first angle is pi over 2. And then 5 pi over 6. And then 3 pi over 2. And finally, 11 pi over 6. So these are the hardest ones because there's so much to plug in. And again, you can use your unit circle to help you. I just really like having this visual. So I've got 0. Pi over 2 is one of the angles. I'm just writing these angles in order where they would show up. So here's 5 pi over 6, 3 pi over 2, and 11 pi over 6. And I just like to draw in the circle here and then use this to help me pick my angles. So you can always plug in 0 unless that causes something to be undefined. So I could pick 0, I could pick pi over 4, whatever. but I'm checking, excuse me, you're checking into the isolated trig function. So tangent of 0, is that less than negative 1 over radical 3? Tangent of 0 is 0, which is not less than a negative. So that's false. Something between pi over 2 and 5 pi over 6. So I could choose like 3 pi over 4. So right here, the tangent of 3 pi over 4, is that less than negative 1 over radical 3? So the tangent of 3 pi over 4 is negative 1. And I know that that's less than negative 1 over radical 3 because this is negative 1 divided by 1 point something. So it's going to be negative 0 point something. That is a bigger number than negative 1. So yes, this is true. Now, again, these should usually alternate, but there's a chance that they don't, depending on if this is like a squared or something like that. So it's best to just go ahead and check these. It's also just good practice in evaluating all these little mini inequalities. So something between 5 pi over 6 and 3 pi over 2. So I would pick pi right here. So tangent of pi, is that less than negative 1 over radical 3? Tangent of pi is 0, which we've already established is not less than a negative. So false. Something between 3 pi over 2 and 11 pi over 6. Remember, the pi over 4 angles are nice with tangent, so 7 pi over 4 is a good one for right here. So tangent of 7 pi over 4, is that less than negative 1 over radical 3? So that's negative 1. Tangent's negative in quadrant 4. So you can see you should be getting like a lot of the same little inequalities because you're checking similar angles just in different quadrants. So this is true. And then my last statement is going to probably be false. Something between 11 pi over 6 and 2 pi, I would just go with the 2 pi there. You don't want to have to start doing over 12 if you can avoid it. So tangent of 2 pi is less than negative 1 over radical 3. The only time you can't plug in 0 and 2 pi is if you're getting undefined. You would need to pick something else or start thinking about signs and stuff. Tangent of 2 pi is 0, which is not less than negative 1 over radical 3. So solution set for this one, this is just less than, so no square brackets. So it's pi over 2 to 5 pi over 6, and 3 pi over 2 to 11 pi over 6. All right, now when is sine greater than cosine? So if we have mixed trig functions like this, and they're such basic functions that it's best to just sketch the graphs for this one. If we have this on our test, it will be the same scenario, but I might switch it to like, is sine less than cosine? Give that interval. So either way, both of those graphs, we should be able to give these basic graphs, right? You go out to 2 pi for the period, cut that into 4 equal parts. Go to 1 and negative 1. So your sine graph should start at 0. Then it goes above midline, 0, below midline, 0. And then the cosine graph starts at the amplitude, midline, negative amplitude, midline, amplitude. When is the red graph above the blue graph? Well, they meet right here at pi over 4, and they meet right here at 5 pi over 4. How do I know that? Because of unit circle trig. Both sine and cosine are radical 2 over 2 at pi over 4, and they're both negative radical 2 over 2 at 5 pi over 4. You're in quadrant 3. Okay, so it's on that interval, right? It's right here. This red section is above the greens, or is above the blue section from pi over 4 to 5 pi over 4. Are we including the endpoints? No, because this just says greater than. So pi over 4 to 5 pi over 4 would be the solution set for that problem. All right, now we talked about number 4 in class, in all of the classes. So without a calculator, I put these questions on here to act like our AP classroom. So Without a calculator, I would still need to isolate this trig function. And to solve for x, to get rid of the tangent, you can inverse tangent both sides. Just like you can take the log of both sides, or you can square both sides, you can take an inverse function or an inverse tangent of both sides. And then the inverse tangent cancels out with the tangent. You're left with x. Now, this goes back to our inverse function days. Remember, this is just a quadrant 1 angle because arctan, remember the rules for arctan, it only went from pi over 2 to negative pi over 2 for, excuse me, for our answers. And so if we have arctangent of something positive, we must be somewhere in quadrant 1. I have no idea what angle makes this happen, but I do know it's in quadrant 1. So I can't just say plus 2 pi k, because even though that would give me the rest of the answers that line up, I'd be missing half of the answers. Tangent is equal to 5 in quadrant 1, but it is also equal to 5 over here in quadrant 3. So instead of adding 2 pi and landing back at our angle every time, if we add pi, we would land in quadrant 3. If we had another pi, we'd land in quadrant 1. Again and again and again, pi is a half circle. So we want to add pi times k. Another way to think about that is just we're adding the period of tangent. The period of tangent is pi, k times. If you just add the period, remember periodic functions have the same behavior if you go a distance of the period from whatever point you're looking at. So if x is equal to inverse tangent of 5, I can add or subtract any number of integer values of pi, and I should land on another answer that satisfies the equation. So these are not inequalities, these are just equations. Now for this one, you could factor. This is secant x plus 7, secant x minus 7 equals 0. So secant x equals negative 7, or secant x equals positive 7. Now with secant, I want to find, you can use inverse secant, or you could flip these around and say cosine is equal to negative 1/7, cosine is equal to 1/7. But here I have two answers. So I want to say x is equal to arc secant, or inverse secant of 7, negative 7, and x is equal to inverse secant of positive 7. And then again, we want to add the period here, which is 2 pi k. The period for sine and cosine, remember, is 2 pi. So we want to add 2 pi k to both of those answers. Again, going back to inverse trig, for arc cosine, the only answers we were able to get were between 0 and pi. So arc secant of negative 7 is somewhere over here. So if we add 2 pi, we'll keep, or subtract 2 pi, we'll keep getting another coterminal answer there. Arc secant of 7 is over here in quadrant 1. So if we keep adding 2 pi, we'll keep landing back there, or subtracting 2 pi. So both of those are true as long as k is an element of the integer number set. This last part is for our calculator. So clear out our old stuff here. So we're allowed to use a calculator from 0 to 2 pi, round to the nearest thousandth. So these should be pretty easy to do. I want to type in 4 cosine squared. So I've got to type that in as 4 parentheses cosine x squared minus sine x minus 1. I'm also going to type in 0. So I want to find, instead of just graphing this and finding zeros, I'd rather just find the intersection points. And make sure that you're in radian mode. To get the graph to show up, the window we're interested in are solutions on 0 to 2 pi. So make that adjustment if you need to. It doesn't matter what you count by. It can be ones or pi over 2 or whatever. Your y min and max just need to encompass this value. So 0 is between negative 10 and 10. So I can just leave it like that. And I'll press graph. And we're looking for when is this graph above 0. So I see that happening right here and here. We need to exclude this little point where we're equal to 0 because this just says greater than 0. So let's find some intersection points. I need to get the cursor closer to that first one. All right, so enter, enter, enter. So our first solution set for when this graph is above 0, we include 0 because at 0, the graph is definitely above 0. It's not equal to 0. So I've got 0 to 0.848 parentheses because this is not equal to. And then the next intersection point, I want to find this one. So I've got to get the cursor closer to that other intersection point. Oop. There we go. Enter, enter, enter. So that one starts at 2.294, round correctly to 3 places. And it would be that to 2 pi if we had a problem that said greater than or equal to, but I need to exclude this one little point where the graph touches and turns at 0, or at the x-axis. So I'll get over here, enter, enter, enter. That's at 4.712. So then the last section of answers is pick up again from 4.712 and go out to 2 pi, but we're not including 2 pi only because it says not to include it in the final answer. Otherwise, 2 pi would be included as well because that's well above, definitely above 0. All right, last problem. When is this above 8? So if I leave everything exactly as it is, then try to clear this out. This is kind of glitchy. It keeps skipping over y1. So I'm just going to type in 9 sine of 2x and compare that to 8. Or you could divide by 9 and do sine of 2x and 8/9. But I'm just going to leave it like this. And then I just need to make an adjustment on the window for the y values. So I still want 0 to 2 pi for the x's. But the y values, I need to be able to see 8. So maybe I go from, I don't know, 2 above, 2 below, 6 to 10. As long as you can see the intersection, that's fine. So this is saying when is this graph above 8? So this little hump is above 8, and so is this one. Oh, okay. It found a weird place. Hold on. I didn't. So this is a good point. So when I hit second calc intersect, if I can't see the cursor, I couldn't see the cursor before. If I'm on the red and I sort of lose track of the cursor, you can always press up or down and have it hop onto the line or the graph that you can see. And then it's easier to see how far your cursor is. I want to get to that far left place. Enter, enter, enter. Okay, so 0.547. We're going to include that since we're greater than or equal to over to 1.023. So here's the first set of answers. Now the next set of answers should be, what did we say about period? We said with periodic functions, this point where the pattern repeats should be pi units away. So I should just be able to add 3.14, but let's just verify that. You might not remember something like that on a test day, but that is how we started periodic functions way back in 4.1. Yeah, 3.14 plus 5.47 is probably 3.68. That seems right. So 3.689. And yeah, this point then should be 1.023 plus 3.14-ish. Again, you can just verify that. Enter, enter, enter. So yeah, 4.165 if we round. Okay, so I didn't have to use all the calculator stuff. I could use periodic and say, well, this has a period of 2 pi over 2, period of pi, and just add that period over there. That works too. And then you guys did not have this problem number 8, so don't worry about that. All right, that finishes this video. I don't have office hours on Wednesday, but you can come Thursday if you need some more practice.